All right, let's do this. But I think what I gotta do first is we got okay. There we go. All right. So how this is gonna go? We're gonna talk about what the angles that are formed by parallel lines, what kind of relationships they create. So before we were dealing with yesterday, we were dealing with pretty much anything. So if I drew a straight line here and a not as straight line here, but then I uh, a transversal cuts across these. Okay. Then yeah, you've got some angle relationships here. You've got corresponding and alternate interior, alternate exterior, and all that. But that stuff doesn't isn't really even all that important unless the lines are parallel. So what we're going to talk about today is when you've got parallel lines. And now let me make sure I draw this all nice and straight. So what we're going to talk about today is when we have parallel lines and the relationship that is formed when these parallel lines are cut by a transversal. That's much more interesting and much more useful. So let's see. There we go. There you go. All right. So and I'm gonna change the color on that one. Okay. So there's your transversal. All right. So a couple things that you're gonna wanna a couple things you're gonna want to know. All right. These are always one of two things. They're always either congruent or they're always going to be supplementary. That's going to make things nice and easy for you. So they're always either going to be congruent or they're going to be supplementary. All right. So in the case of corresponding angles, and this will be our example one. So example one, if we're talking about corresponding angles, and remember, corresponding angles aren't those the ones that are matching, right? Matching in position. All right. Corresponding angles are always going to be congruent. All right. Corresponding angles are always going to be congruent. Corresponding angles are congruent. There's a whole postulate for that and everything. So corresponding angles, when cut by when the lines are parallel and cut by a transversal, they're going to be congruent. All right, and that's that. Don't forget that's that symbol here. So if you were to see, if I were to tell you, if I were to label this as, I don't know, this can be A and this can be B. All right, and I'll tell you that this here is 80 degrees, and this down here is X degrees. Right, and they say solve for X. Well, it's going to be real simple. It's just going to be X equals 80 degrees because, once again, the corresponding angles are congruent. Corresponding angles are congruent. So this angle here is exactly the same as this angle here. Okay? But what if we made it a little bit more, what if we made it a little bit more difficult, which is what they're going to do. It's their job to make our lives a little bit harder. So let's draw another transversal here, okay? And let's see. Notice this one's a little bit different. Okay? Um, and I'm gonna put an equation here that I'm gonna put an expression here this time though. I'm gonna say that this angle here is 2x minus 45 degrees, right? And this angle here, I'll draw a arrow to it. This angle here is x plus 30 degrees. All right, so now they want us to solve for x. So what are we going to do this time? Well, since they're congruent means that the measures of these things will be equal. The measures of these angles will be equal. So just like I did here, I'm going to say the exact same thing, just slightly more complicated. I'm going to say, well, that means that 2x minus 45 is going to be equivalent to x plus 30. And now the rest is just algebra. I'll subtract x on both sides and I'll add 45 on both sides. And so then x is going to equal 75. And there you go. Done. Done deal. Done deal. Okay. Let's try another one. Okay. The other ones that are congruent are alternate interior and exterior angles. Okay. Those angle relationships are congruent as well. So if I ever told you that, let's see, let's say that this angle is, let's go back. I'll just call this angle X, and I'll call this angle 125. You could easily say that angle X, since angle X is congruent to, I'm sorry, angle X equals 125 degrees. Period. Because those are alternate interior angles. All right? And it's the same for the exterior angles. Um, we're talking about this angle here and this angle here. Now we can actually use a little bit of geometry logic that we have as well. We'd say, well, aren't x and this angle here, I'll call this angle A and we'll call this angle B. Aren't x and angle A vertical angles anyway? Sure they are. And at 125 and angle B, aren't those vertical angles as well? Sure they are. So these alternate exterior angles will also be congruent. So we'd also be able to say that angle A is congruent to angle B, which then also means, so there's those little symbols for therefore. We'd also be able to say whatever the measure of angle A is going to be equal to the measure of angle B. Okay? And we know what the measure of angle A is. The measure of angle A would be 125 and 125. There we go. All right. So those are also congruent. So now let's look at ones that would be supplementary. So first of all, corresponding angles are congruent. Alternate interior and alternate exterior angles are congruent. And so now let's look at the kind that will be supplementary. With same side interior and exterior angles, what we're about to say should be a little bit intuitive. All right. So if I'm looking at this angle right here, all right, then we'll just, I don't know. So if we're going to go to the same side in the interior, all right, so I'm going to stay on this side of the transversal and I'm stay inside the parallel lines. So now it brings me to this angle over here. Right? And it should be obvious right about now, these angles aren't the same size. All right. One of these angles is acute. That'd be this angle here, the blue one. And the other angle is obtuse, meaning greater than 90 degrees. And that would be this angle up here. So already they don't even look congruent. So we shouldn't even assume that they're congruent, right? But as long as these two lines are parallel here, all right, we'll just call it, we can name these lines. We can call this line L and this could be line M. Okay, they use cursive letters when they're naming lines. This can be transversal S or T. Let's call it T, transversal T. Anyway, so they're obviously not congruent. So the relationship is supplementary. All right, the relationship is supplementary. So if I told you this, let's make it slightly complicated. If I were to tell you that this angle here is X, oh come on, don't be ridiculous, is X degrees. How much is this angle? It would have to be whatever 180 minus X is, since they're supplementary. Okay, it has to be that. So if I were to tell you that, uh, excuse me. So if we were to say that this angle here is 125 degrees again. This angle has to be, well, we can work it out. Whatever 180 minus 125 is, and that's going to be 55, right? So this would have to be 55 degrees because these two angles have to add together to be 180 degrees. Okay, so if were to draw one more real fast, all right, just to do one more example. So these lines might not be perfectly straight, but I'm going to do the best that I can. And I'll put my little symbols on here, little symbols that say that these lines are parallel. Um, okay, and we'll cut it with a transversal right here. All right. So let's use expressions one more time. If I were to tell you that let's do alternate let's do same side exterior angles this time. If I were to say that this is 13x degrees, and this one down here is 23x degrees, and they've asked us to solve for x, how would we do that? We're not going to set them equal to each other because remember, look, 13x, the angle is acute. That's smaller than 23x, which is obviously an obtuse angle. So don't even think that we should set them equal to each other. Instead, we're going to be able to add them together and they'll be 180 degrees because once again, we said these are supplementary. So to solve for it, you would just say, okay, well, 13x plus the 23x is going to equal 180. And then you'll start to solve that. That'll be 36x equals 180. Then you'll go ahead and divide by 36 on both sides. And I think it's, yeah. Yeah, and you'll divide by x on both sides, and that should give us 5. X is going to equal 5. There we go. And what if they wanted to know, and they could have labeled it, and they labeled it with different letters and stuff like that. But, uh, but excuse me, I'm sorry. So what if I wanted to know what is the angle measure of this 13x? Well, we'd just plug that 5 in. So we'd say 13 times 5. Okay, and if we want to know the other angle measure, we'd say 23 times 5, and we'd have our answers that way. You know what is 13 times 5? I'm tired. 5, 1, 6. That would be 65. You know what's 23 times 5? It's 5, 1 is 115. And if we double check ourselves, when we add these two together, they equal 180 anyway. So we know we've done the right stuff.